Hello, everyone, and welcome to the January 2025 ZFS leadership meeting. I think we actually have two this month because we do it every 4 weeks. So this will be the first one for January, but thanks everyone for coming. I guess the first thing we have as we get started is Brian has cut another release candidate. So we have RC5 of 2.3 is out, includes a couple of last minute changes, especially around some work Don Brady did so that if too many vdev probe errors happen, that will suspend a pool. And also that we clear the async remove flag when we are attempting to reopen vdevs when we're coming back from a suspend. But yeah, we're now at release candidate 5, so we should be pretty close to the final release of 2.3.
Yeah, I talked to Brian about it end of last week, and he promised to have a release actual at next Monday. So fingers crossed, hopefully nothing else happened before that.
Yeah, I don't think there are any other known issues, so that'll be great. Tony, do you have any more input on that?
Sorry, is this on 2.3?
Yeah.
Yeah, I just talked to Brian, and he's thinking next week, hopefully early next week.
Yep. So there's no known issues or anything?
Yeah, I don't think so.
Yeah, great.
Even in RC5, most of changes for some Ztest fixes and so on. It should pass in test pretty nicely lately. I've made a few fixes to make it pass on FreeBSD 15. Unfortunately, with CI builder we have right now, there is a problem in FreeBSD diff implementation, regression actually in 15. It fixed it upstream, but we need update of CI for it to pass clean. Quite regularly, there are issues on I can see on Ztest, and they're quite often random. I haven't looked close, never been there, but it would be nice if somebody investigated those and helped to sort them out. Then we could have really clean CI much more often than not.
Yeah, Matthews from our team is starting to look at Ztest specifically and looking at those failures, and we'll maybe try to pull in the hackathon project from the Dev Summit where they made it that when Ztest does find something, that it gives you the inputs to run that exact same test again, rather than it just being always random, which might help track some of those issues down a bit more, and also even just isolate the ones that are actually purely random versus the ones that are deterministic but only happen in a weird combination of circumstances. So yeah, being able to harden that a bunch and get a lot of those cleaned up so that when Ztest finds something, we don't assume it's bogus, but actually know that hey, that probably means there's actually a problem here. Another one I wanted to talk about, we got a kind of feature request that both came out of the user side of the summit we had back in October, and another request that we got commercially about extending the ZFS permission set, so the ZFS allow system, to allow ZFS send, but only of the raw data set. So allow you to do a send, but only with the -w flag. So if a data set is encrypted, that you can't ever send the decrypted version of the data set. And looking for other people that would find that particular functionality useful, both so that we can kind of set the user experience for that and make sure that we're covering everybody's use case, but also interested in other people that would have a commercial interest in that specific small feature.
That definitely sounds like a good feature when you need to send receive between untrusted systems during backup somewhere or restoring from somewhere, things like that.
Exactly,
just,
that's the use case.
well, yeah, it definitely makes sense. My only thought that it would be good to, since effectively will be a security feature, would be good to audit the code, make sure it cannot be work around it and bypass it somehow to get raw data in some ways.
Right, or in this case, the not raw data, but yeah.
No, yeah, not raw data, yeah, different ones. We have for years, and recently there was more activity, more noise from people who complain about encrypted replication. And it feels from later reports that we have some race between multiple sends or who knows what. And I have that corrupt the data on the receiving side, or if somebody reported some error on sending side, I'm not sure how, but I have feeling we have some race between encrypted and non-encrypted data somewhere. Because obviously DMU layer cannot handle both same time. It's either one or another. And attempt to do something wrong will likely not have good results. It's just another thing that somehow needs to be diagnosed that may or may not be related. I just worry about potential leaks of plain text data in that case. But it may be totally unrelated. It's just same area with
probably unrelated, but definitely something that it'd be good to get some eyeballs on and try to figure out what's going wrong there. We've had a couple of patches lately that have definitely improved the state for encryption, but there's probably more that could be done still. Because there still are quite a few reports of issues, especially about high levels of replication. I think there's actually one issue report somewhere. I don't know if it's actually in the ZFS repo proper yet, but somebody reporting an issue with one of the replication tools around the difference between using capital R versus sending each of the data sets individually. And it seems kind of to your point that possibly the timing affects things there, where if you use capital R, you receive multiple data sets close enough together that it changes something, versus if you send them individually, then it's more ioctals, and so its timing is spread out more. It might be a place to look.
I had one suspicion about the point when we completing receiving stuff and after that mounting file system. I understand there should be always transaction commit in between and cache eviction. But if somehow it doesn't happen, we may end up with buffers that are still encrypted after receive, but accessed as plain text as during the mount process. That's not good. But I was unable to find how would it happen. I have no clue. But yeah, if some parallel receive somehow possible, then I guess it may cause some races in that area.
Yeah. Definitely a place to look at. But yeah, if anybody watching the video for this or whatever is interested in these changes to the ZFS permission delegation, please do get in touch. I guess while we're on the topic, the first of the open pull requests that I have highlighted here is around the function receive fix encryption hierarchy, which resets the encryption hierarchy as you insert new data sets via replication. This change mostly seems to be optimization to finding the matching snapshot. So George has got a proposed change here that apparently reduces the CPU time it takes to match up the snapshots on receive by what seems to be quite a bit. So it'd be good if somebody could take a look at that and give it the code review it needs. Yeah, apparently it changes the time it takes to finish the receive from several minutes to just a few seconds for 1,000 file systems, which sounds like a pretty big pessimism that's left there currently.
Yeah, it was on my radar, but I haven't looked closely on it. It seems like in something libzfs I'm not much familiar about. But we had some other reports that during receive, the moment we complete receive, there is some load spike. I forgot the detail now, but we're also doing something bad at that point unrelated to this.
Mhm.
I think it's remounting and updating the node pointers for everything.
Yep.
So that it also takes some time and pretty busy for a system.
Yeah, and if you have a lot of data sets, it can add up. And Don's not here today to talk about it, but he does have his pull request up for his code to detect slow raidz children during reads. So basically, this keeps a short history of latencies on all the members of a vdev when it's raidz or draid, and basically recognizes when one particular disk in your vdev is a lot higher latency than the others, likely due to it, failing or just being overloaded. And in the current form, it will basically sit that disk out for the next 5 seconds, hopefully allowing that disk to kind of clear whatever backlog it had and go back to performing normally. So during that time, we treat that disk as if it was offline and use the raidz reconstruction to, rebuild the parity and be able to return the data to users, ideally not as slowly as if we waited for the IOs to complete on the disk that's being slow. Then after that 5 seconds, the disk goes back to normal. And each time that happens with the little sit out period, it increments a counter and then raises the right events for the fault manager so that, if it happens, so many times in an hour or something, you can, proactively decide to replace the disk or whatever, or to permanently offline it, but allows the system to kind of react autonomously to this and differentiate between a disk that's temporarily a little bit slower versus a disk that is, starting to fail and is dragging down the performance of the whole pool. When we've seen disks that are, on the way to dying, they can really pessimize the performance of the pool. As when you're trying to read a raidz, you wait for every disk to finish its read, and if one is taking 4 times longer than everybody else, it really slows things down.
Do you target it mostly for SSDs that may need time to clean up the FTL and do some homework, or it's...
No, this is mostly for hard drive use case of just, when the drives are doing too many retries internally, or the error correction is taking too long, or the disk is just really taking 50 milliseconds instead of the normal 4 to do stuff. One of the tests Don did with it was an SSD vdev with one hard drive in it to kind of simulate one disk being a lot slower than the others. But in general, the use case for this is mostly hard drives, but would apply to SSDs, like you said. If it has a garbage collect pause or something, then that is something where you'd want to maybe not bother that disk for a couple seconds and let it finish what it's doing, but not, immediately decide to offline it. Whereas the current mechanism we have with the slow IO means that, if the IO is so slow that it hits the timer, which I think is 30 seconds by default, then eventually we would try to replace it, which might not be the use case. Although the big thing with this is that it's looking at, is the latency of this disk like outside the bell curve by 2 orders of magnitude from the other disks. So basically, is one disk, significantly slower than the others, not, having a specific threshold like, it took so many milliseconds to do a read.
Yeah, I'll do another look through it after some updates done there. I was a bit suspicious about reliability of the data previously, but yeah, it was rewritten and I need to take another look. But I generally wonder what chance that hard disk will ever recover from that, unless it's also some disk with SMR that also may need some time to do cleanup inside to handle FTL. If it's normal disk with normal CMR plates, then what would it do to recover other than maybe cool down a bit? And also, since it applies only to reads are still going there.
Yes, writes
we
still have to
we
go.
cannot skip writes.
Yeah, and mostly this is kind of a way to try to detect the situation where the disk is bad, because most of the times, yes, it's probably not going to get better. It was just, our original idea of, opting into just always reading the parity and returning as soon as as soon as you had enough blocks to reconstruct it, was a bit hairy, because then, sometime in the future, after you've already finished the ZIO, you get a completion for this other read that you don't want anymore, and so on. And so that's why we kind of pivoted to this design, where, we give a disk, it's not just one time it was slow is enough to knock it out, but we keep seeing this pattern, and if it doesn't get better, then that it gives you enough data and events with Z that you can decide to offline or replace the bad disk.
In case of those disks you experience, do you see all retrials within the disk on single request, or sometimes it turns error and be retried by OS? I remember we previously discussed fail fast
The
option
fast, yeah.
that needs some love to make it more efficient.
Yeah, in this case, it's mostly, it does succeed eventually. I think usually without any errors, it's just that the latency is significantly higher than with the other disks. So I think some of the time it is getting the error back to ZFS, and ZFS is issuing a retry. But some of the times it's just, the disk's internal ECC or whatever being slow enough before it even gets, to the hardware retry.
No, yeah, when we get to ZFS, it's already on our side, but without fail fast set, it would also had some retries
From
on
the kernel.
Kernel side. And if we are doing, when we're doing raidz and we're doing first request, we could do it always with fail fast, since we know there is redundancy, and we can do it more optimistically. If that fails, then we could try to use other disks rather than retry this one, maybe.
Yeah, that's another good idea. Like you said, fail fast could use some love. Any other thoughts on that one? Yep. Okay. Next one Don has is the raidz file layout. This is the one he demoed at the developer summit. Basically allows you to kind of visualize how the data is laid out on raidz. So which blocks went to which disks, and understand, I know Alexander and I have both talked previously about wondering, when we see kind of the uneven performance across the members of a vdev, how much of that is just because of the way files got laid out and so on. And so being able to visualize that and see, how a bunch of files stacked together, and which blocks went on which vdevs and so on. It seems like a very useful tool, although I know Don had thought about what to try to do to visualize draid, but that's probably a little hard to do with ASCII art.
I don't exactly remember why I put revision needed, but at very least it doesn't pass most of the tests, so it needs some cleanup.
Yeah,
at least to not break things.
Yeah, I think it's all in ZDB, so I don't know how it would have broken that many tests, but yeah, it probably just needs a refresh and make sure any of the failures are dealt with. Then there were two new ones from a relatively new contributor. One, they found that when unmounting a file system on Linux, mmapped pages aren't necessarily synced before the unmount happens. And that could leave dirty data that didn't get written back to the file. And they found this running like the package manager inside a container and then stopping the container. And when it got unmounted, but the with no msync call, the mmap pages didn't actually get written back. And then related to that, they found that the same can happen when you call syncfs to try to sync all file systems. Those mmap pages look, again, not to actually get fleshed out properly.
I wonder why it's not problem of the kernel. Like, who should handle it normally?
Yeah, mmap is kind of a special case because ZFS is copying things back and forth between the ARC and the buffer cache, but it does feel like the kernel should be, taking care of that as part of pre-unmount, right?
Yeah.
But in the syncfs case, if we were specifically asked to sync stuff, then it seems like that's something that should be happening, but it's not clear.
I think if you have anything mapped, I don't think ZFS should be able to unmount it at all on Linux. It should return error or stuck or
Right,
whatever.
it's busy, yeah.
And if you already closed the file, that shouldn't there be some sort of contract that once you closed successfully, it should be already somewhere in progress at the very least?
Likely, yes.
So yeah, I haven't looked much in that PR science. I can't say much about VFS, especially on Linux, but it makes me a lot of thoughts.
Yeah, it really does raise the question about some of these contracts here. It's like, how much of this is not actually our responsibility, right? How much is supposed to be the kernel, flushing that stuff as part of the close or unmount versus that being the responsibility of each file system to implement. Then the next one is one that we're working on, the zpool condense command. So the first iteration of this is basically for flushing the spacemap log so that, when you go to export the pool, it won't have to spend a bunch of time doing that. And that way, when you import the pool, it'll be faster. Very helpful for HA. But, we're also looking at extending this for fast dedupe as well, so that its log could be flushed in the same way to basically force the whole log to get written back to the DDT. And then, any other things that might do the same thing, we've talked about maybe BRT needs a similar log mechanism because, we're investigating some reports now of when creating huge amounts of clones, things are kind of bouncing around and causing the clone file range stuff to take a rather long time, especially if you do a lot of deletes all at once. It can make the transaction stall.
Yeah, right now we have very small block size also for block cloning, only for BRT, only for K. I haven't really got to measuring whether it could be increased, but would we have a log, we could definitely increase it, same as we done for DDT. So I think I've done all optimization I could from a side of avoiding disk IO, but once we're already there, I'm not sure what else to be done other than adding the log. I was thinking for some time whether we could implement some sort of custom hash for the BRT so that data, since we in most cases have data locality quite strong. If you're cloning file, big one, usually you have blocks sequential or close to each other. It would be cool if we could store them in the same zap leaf, but I haven't got any good ideas how to do that without risk of overflowing that leaf or significantly imbalancing the tree. So as a result, we end up with BRT zap randomly accessed on both reads and writes. That significantly affects performance. And I was able to avoid some cases that supposed to be avoided from the beginning, like you're doing first clone or you're removing removing and adding again, or some other cases when we may skip zap accesses. But when zap accesses are needed, then it may not be exactly perfect.
Yeah, I think some backup software and so on using this is starting to do it at a scale that is maybe a little different than what we'd seen most of the existing BRT usage with.
Yeah, we have a project with Vim trying to make them work better with ZFS, and they are able to support it now. The one issue that remains that they don't accept on their side, but somehow stuck in limbo, is that they require clone to always succeed, never to fall back to copy. I don't know why, but that's what they're doing on Linux. And in case when data just freshly written and immediately should be cloned, we return error because data not on disk yet. We have tunable for that, but you should know about the tunable to actually safely use Vim. And in other cases, the tunable is not helpful. So I'm not sure what can we do about it, but that's one of the issues there. But
Yeah,
otherwise,
the tunable is a bit of a pessimization, right? Because it means you have
it
does a sync before every attempt to clone or something like that, right?
Not every, but yeah, it potentially gives attacker chance to throttle the pool badly with special manually crafted pattern. So like right clone, and pool will just go all in sync, and you can DDoS the system. But question how to do it better, that's open one. Otherwise, that was the thing that actually broken the backups. Aside of that, that remains potential question of performance, but the users who was testing that was reaching something like 20 terabyte size. But yeah, I think if would they go another 1 or 2 orders of magnitude, then things would get even more interesting on BRT side. But he just haven't got there.
Yeah, like I think the case we were looking at, they had a very, very large BRT to the point where like they were freeing 100,000 blocks or more in each like free chunk. And we were trying to throttle that a little bit better. But yeah,
throttling of that is indeed right now it's not done right. For dedupe blocks, we know that they dedupe and we can chunk them. But for BRT, we don't know that. And right now we're trying to freeze them all in one TXG. That may be too expensive, take too long. So if you find some good ideas how to do it, sure, would be interesting to see.
Yeah, and trying to find the right way to kind of.
I think it was discussed with Rob on some of the PRs, and he complained that it's too expensive to check whether the record is in BRT, but I optimized that and removed log acquisitions from there. So it should get cheaper in last couple months in 2.3. So maybe we could do it in more cases, just in case. Sure, it still has a cost, but much cheaper than it was before.
Yeah. Lastly, Tony, you had a feature proposal for zpool status to kind of add arbitrary additional columns from like vdev properties.
Oh yeah, this was just a quality of life improvement that I think might help. So basically right now, if you use zpool status-c, you can run all these little scripts against all your disks and get things like smart stats or check if the fault LED is on. And I was thinking, well, could we extend that to also display vdev properties? More specifically, I was thinking about Don's patch because I want to see if a disk is sitting out in zpool status as its own column. And so I haven't written any code. This was just an issue, but I thought it could be useful.
Yeah, I agree about that Don's patch argument, and sure, many others could be helpful too. The only question, how could we handle conflicts if the same property could be both per dataset and per vdev? Well, I think you mentioned that only one possible Z size now, but shall we deny it in future, or we could invent some special syntax?
Yeah, I think right now the -c is scripts for it looks in a certain directory and so on. Does it make sense to have a different flag specifically for properties? Like, obviously -o is what we use for, selecting the columns on like ZFS list and zpool list and so on. So that's the one that immediately occurs to me, although a little bit weird in this case in that it's not actually pool properties, but vdev properties that are being selected.
Yeah, I agree. I haven't used -c and those scripts ever, but it makes sense to not conflict even with script names or whatever it's used otherwise. So -o could potentially have sense, I think. But yeah, what to do? Just then remains conflicts between pool and dataset,
Well, we could,
or pool and
since,
vdev.
yeah, and I don't think a pool one ever makes sense because it's going to list it per vdev. And so pool properties wouldn't make sense. And so we could scope it specifically to this will only ever be vdev properties.
Maybe so.
Because like printing a pool property for every disk seems weird.
Should we show it for a pool on a pool row? Or...
Maybe, although at that point you're better off just using zpool list, right?
Potentially yes, but I can potentially see when state situation when I would like see both state and some like space usage or things like that.
Yeah. So was it zpool create? We have small o and big O to differentiate pool and dataset properties.
Yeah.
We could maybe do something like that so that you had O for pool properties and big O for vdev properties or something.
Yeah, or I just thought we just for a row of a pool we could show only pool property for data for other rows of vdev we show only vdev properties. Maybe it would be okay. Maybe
Yeah, it just I think it'd be weird because the properties that exist for one and not the other. How do you display them? But I guess
yeah, it would be some
because of the way you have to do the columns, you're going to have to do
dashes.
that anyway. So yeah, I think just one and have it contextually switch makes sense because when we print the headers, we're going to have to just have all the columns, and so it's not like we'll be able to have different columns for the pool than the vdev. And so yeah, we should be able to do it all as just one.
Do we have stats for top level vdev? I guess we do.
We do.
Then
yes.
we would definitely. Then if we want to show top level vdev counters, then we won't get any pool properties at all. So.
Right, because the pool is also the root vdev.
Yeah.
Yeah. Yeah. Because we had to add a special keyword for that. Because when you're doing the zpool get and so on, you can specify a list of pools or a pool and some vdevs. And so if you put the same pool twice, it didn't understand that the second time you were trying to mean the vdev. That happens to have the same name as the pool. So yeah, it looks like it would have to be pool or vdev properties only, but that should be fine.
Yeah, I think you would want to be careful to not have any name collisions because
yeah, and that's why I think scoping it specifically to, this only does these vdev properties, and so it has to be a vdev property, and that will avoid any name collisions.
Well, you could pass like -o and then size, and then -c and then size, and then you'd have two columns named size.
Size, and how do you tell which one's which?
Problem with the JSON. But the other benefit of this is that you don't have to necessarily add in a new flag to zpool status when you want to add another column in there. Like, for example, we added the slow IOs column. Well, you know, if you go back in time, it would be nice if you could just make that a vdev property and not have it as a special flag.
Yep. For sure.
So that's all I've got for that.
Yeah, I was mostly just figuring out how to deal with those collisions and if it makes sense to have one new flag or to try to shoehorn it into the existing flag. It's just, I can see, you know, since those scripts are arbitrary, there's not like a defined list of what the -c variables can be, right?
Yeah, you just have to be careful or come up with some other solution or prefix all the -c columns with something.
That was my immediate thought, but then it's like, well, that changes how it works now. Whereas if we make all the vdev property ones be prefixed, then that's always been that way. But it seems weird to prefix the stuff that came from ZFS and not the stuff that was coming from outside, right? So it gets,
yeah.
Yep. Okay. Were there any other items that people wanted to bring up?
If nothing else, I'd like to just bring attention that we have at this point 141 open PR, and it fluctuates about that level plus or minus for quite a while. We have a lot of PRs going back for years. I've made a couple passes back and found a few PRs that I could close, and I know a few more that could be closed as no longer applicable or require significant rework or something. But if somebody has something open that's either abandoned or require rework, and somebody could jump in and actually push it through the line, it would be great. I don't want to look a bad guy just closing somebody else's PRs, but on the other side, there are a lot of PRs that are this close to be finished, but not there yet. And yeah, for example, there is PR to implement some ioctl, how is it called, to optimize random sequential accesses and so on. It's kind of implemented, but it could potentially be improved or done better, or at least it needs to be rebased and retested, and somebody needs to do it. Otherwise, it's hanging there for a year or two, and what shall I do about it? So if I can motivate anybody to jump and finish things, or just get to agreement that, okay, yeah, let's close that, then would be great. Otherwise, I already had several hot discussions with people who was arguing why my thing was closed, and I had to explain long and painful why I did it.
Yep.
And yeah.
Yeah, thank you for the work you have done. I noticed that, you know, after you get to the end of page 2, you're already back to 2023. So you've done a great job of cleaning up all of the recent stuff. But yeah, there's, you know, page 3 through page whatever to get to 141 are all things that have, you know, were opened in 2023 or older. And like you say, a lot of them, there's good stuff there. It's just they've not really been progressing. And if we can get some of those cleaned up and landed, that'd be great. And if they're not going to, if that's not going to happen, then we maybe look at what to do about it.
Yeah, a couple more that comes to my mind in case somebody has comments here. For example, we have PMM optimization for ZIL that was written specifically for Intel DCP-MM. And from one side, we no longer have DCP-MM. From another side, I reworked ZIL locking, so I'm not sure that optimization is so much needed anymore. From one side, there could be remaining some good smaller patches in that huge PR, but I can't make myself dive into that hunting for something that may or may not be there. So I tend to close it, but from our side, it's kind of completed work that we may no longer need.
Yeah.
So if somebody feel it's needed, please jump in there and try to fish it for something still useful. Another thing, it's another big project, was I think DMU, which was accepted, reverted, updated a couple times, got stale a couple times. It's from one side, it has good intentions, but from my personal opinion, it so much complicates internal designs that makes me shiver. And science PR we have open right now, it's again got too much stale. I tend to close that one unless somebody scream and yell, no, not again. So,
yeah, I agree. Like that one would be nice to have, but it would need a lot of work. And even then it's, yeah, I definitely worry about if it makes every future modification of ZFS that much more complex, then it gets to be an issue. But yeah, we'll keep looking at what we can do to get some of those things landed, especially now that, 2.3 is done. It'd be good to get a lot more of this stuff landed.
Yeah. Some things like arc eviction, DMU, debuff eviction, it's there in progress for quite a while, and they're getting more or less close to this arc eviction. I don't think debuff was worked much, but it needs some final push. Seems like.
Yeah, I did a refresh of the arc eviction one this morning, hopefully to get a CI run on that. Because most of the failures were timeouts and so on, and so I wanted to see if something was actually broken or if it was just the state of CI at the time. But yeah, hopefully we can push through that and get a couple more of these landed and then start working through that older stuff.
Cool.
And then, all the stuff we talked about at the Dev Summit that's coming up. Well, plenty of new pull requests, but we still do have to deal with the old ones.
Yeah.
All right, thanks everyone, and we'll see you again in 4 weeks. Yeah, our next call will be January 28th, back at the usual time of 1 p.m. Pacific or 4 p.m. Eastern. Right. Thanks, everyone.
Thank you.